Hello everybody, my name is Craig Bennett, and today I'm going to get into a networking CCNA, CCNP video, and we're going to get into subnetting. Now this is extremely important. If you don't understand this, do not do your test, your CCNA, CCNP test, and if you're just for general understanding, then, whatever. But as far as that goes, I'm just going to, go into Notepad, and the way I can quickly show you subnetting, or at least a quick understanding of this. So as far as things goes, for those of you who do not know, a normal IP address for a home or whatever, you might see 192.168.1.1, or maybe something like 10. Whatever, as long as it has 4 octets. Each one of these, as separated by a dot, is called a octet. And you might see any subnetting area for normal home use, 255.255.255.0. This is a class C. I'll get a little bit more into that in a second. But the important part is this is for networking purposes. This is a /24. You might see something like whatever the IP address is /24. And maybe you're doing managed switches or routers or something like that. You'll definitely see that. So that's something to note. But why is it like that in the first place? And in fact, why is it called an octet? Is because each one of these is 8. It's in binary, and basically it's represented by that by the following equation. What happens in order to figure out the like I said, for example, we made 192.168.1.1. In order to change this into binary, which is necessary for the subnetting, what you need to do is use the following equation. Is each one of these is a placeholder. So this is 128, 64, so on, so on, so on. And basically what you're doing is adding. So in this case, we're trying to get 192. So if you add 128 plus 64, it gives you 192. And, that's the actual binary form of 192. Whereas something like here, if we have 168, it is 128 plus, and this is how you go down it, by the way, is you go from the highest number to the lowest number. And I'll show you how to get this, by the way, so don't freak out. I know I'm going a little bit fast, but we're going to be covering quite a bit in this. So you go 128, and then let's say, what is 64? And that's too high, so go back to 128 plus 32, and so that in this case 128, it fits within 168, so that's true, so that's 1. 64 will make it too high, so that's 0. 32, that fits in with 168, so it makes it into 160, so it fits in 168, so that's true. 16 is too high, so it's false. 8 is fits into 168, so that's true. And obviously the rest of these will make it too high, so they're going to be false. And that's fairly simple. That's how it works. Is basically use these placeholders and add them. It's a simple arithmetic. It's a simple equation as far as adding this to this. Is it too high? Then add this to that. Or let's say, for example, this is too high. Does this fit into one of these numbers? I say, for example, does if this was 68, for example, 64 fits into that, so it'd be 0, 1, and obviously 32 would make it too high, so that'd be 0, Because 16 make it too high. Same thing at 8, and same thing with 4. And I mean, 4 will be it, and 2 and 1 will be 0. So it'd be, if this was just simply 68, it'll be 0 1 0 0 0 1 0 0. Simple as that. So as far as that goes, how do you get this number in first place? Well, basically what you need to do is a times 2. So 1 times 2 equals 2. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 32. 32 times 2 equals 64. 64 times 2 equals 128. And all you have to remember is you're going to 8. So when you say 1 times 2, you're starting with 1. So that's 1. So 1 times 2 is 2, and that's the second. And then goes from there. And he's basically going in to the 8th number, and right from right to left on this case. And hopefully that will keep you straight. Just remember times 2, starting with 1. 1 times 2 is 2. So you know that your first is going to be 1, and the answer to that, whatever it is, in this case being 2, is the answer to that. And then just times that by 2 and keep writing it left until you get to the 8th digit, the 8th one, which would be 128. So hopefully that will help you on the test. But as far as this goes with the representation and everything, if it that's 255 all ones, and if you add up all of them, that will add up to 24. Simple as that. So that's where the /24 comes in. It's just a little bit long-winded ways, but if you're wondering about the /24, that's actually where it comes in. It's fairly important to understand it for subnetting, because you will see that quite a bit. And basically, if you don't know off the top of your head, like with me, I've been around this for long enough where I'd say /24, it's a class C, 255, 255, 250, and basically I can go from there. Whereas, let's say, for example, I didn't know that added up to that, and all I get is /24, because, like I said, in manage switches and routers, that's all you get. And so what you would need to do is just do, a bunch of ones right there. Or you can use a subnetting calculator and just go by that method. But for the CCNA, you're going to need to know this fairly deeply. So where does this all really come in play? And this is fairly important, is for CCNA purposes, it's a logic AND. A logic AND is basically, it has a truth table. A truth table is basically saying, so truth is 1, false is 0. Simple as that. So 1 and 1 equals true. 1 and 0 equals false. 0, 0 equals false. Simple as that. So basically, what happens here is the router does a AND. It looks at the IP address and the subnetting, and it puts it one above each other. It doesn't really matter which one you put above each other. It's just that you need to put one above the other. And so we got both of them have 1s for the first one, so it's 1. Both of them have 1s for the second, it's 1. One of them has the 1 and says 0 is false, and you keep going down until you get to the end. I'm going to mention something real quick. Since this is a 0, obviously this is just going to be a 0. That's simple as that on that particular one. But basically, this is the network. This is where the router was sending stuff to. But that's actually the final answer of this. This is 192.168.1.0 in binary, by the way. But that's fairly important. That's fairly important for the test. Is you need to understand this is basically it's all added up to the truth table down here. Is so we got 1 and 1, and that equals 1. 1 and 1, that equals 1. 1 and 0 equals 0. Obviously, with the rest of these being 0, then it's 0. And same thing down here. It's like that. It's fairly important. It might seem very obvious. Okay, you have 0, just multiply that with whatever it may be, and that will get you a 0. But that doesn't really always work that well. As far as it can be too hard for some to go by that route. So what happens if it's something like a 28, so /28? So now we got a 192.168.1.1/28. Well, all right. Well, tell me what is 28 off the top of your head, and feel free to pause and put in your notes or in the comment section or whatever it may be what you think it is, and just follow along with this. So what it is you simply go down and let me see if I can get a little bit more space on here. So just for the subnetting, that's all we're going for, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's just 28 ones. Instead of me just doing all that, I'm just going to say it's 28 ones, and that way I don't miscount. But it's important to note that 1, 2, 3, 4, 5, 6, 7, 8. So it's that's in binary. So it's 28 ones. And if we use the formula as above, it's obviously 255, 255, 255, and then this last little bit. If we use the formula above, we have 128 plus 64 plus 32 plus 16 equals 240. That's a /28, and that's how you get it. It's because in managed switches and routers and stuff like that, or on pieces of paper or whatever it may be, that's literally all you're gonna get some of the times is the IP address and the / whatever it may be, because it doesn't take as much space, and that's just how the systems work. So with that being said, now let's use this to our advantage. So let's go ahead and copy the 192.168 binary, put it down here in the new subnetting. So like before, you're going to have the 192.168.1, and in this case, what we have is, so 1 is 0 is 0. All of these are 0. So it's going to be a 0 at the end. But let's just change that around, because I'm going to be a bit lazy. Let's change that around and figure out something like, I don't know, 50 or whatever. Let's do 50. So as far as that goes, what we want to do here is, for the IP address, is use the math form as above. So 128 doesn't fit in 50, 64 doesn't fit in 50, 32 does. So 32 plus 16 equals 48, so that'll be 1 plus 8 equals 56, so that won't be it, plus 4, that won't fit, plus 2, and now it be 50. So 1, 2, 3, 4. All right, and in binary that will be 50. So what we need to do is we would have 0, 0, 1, 1, 0, 0, 0, 0. And what this is going to be is now we need to go down and take a look at this. So 0, 0, 32 plus, it'd be 48 obviously, because we already went through the math. And now we got 48. And this is what you need to know for the tests. Even if you are not going to take the test, this is what you need to know in order to do the subnetting stuff. Is this. So out of this, I'll say the most crucial to know is that. If I have any teachers in the audience, make sure that students know this specifically, how to get from 1s to 4 to whatever, and go from there, because in tests you can quickly figure it out. So is what's the 8th place and whatever. It's fairly simple. And if you're out on a field, if you don't have access to a subnetting calculator or whatever it may be, you can easily figure out, okay, 1 times 2 equals 2, 2 times 2 equals 4, go down that path and get all the way up to 128 and go through this stuff on top of your head. Now, here's the thing, is for the actual test, let's make this a little bit bigger and everything. So what we need to know is, what does this mean for network versus broadcast? So as far as, let's go with the first example because I almost forgot this. What you need to do is this one right here. Go with this right here. So this is the network number. It's the first number. So we're just going to do net. The broadcast number is the last number that will be there. I'm just going to put P for that. The host numbers is 1 through to 54. And basically what it means is, for your devices, they cannot hold 0 and they cannot hold 255, but they can hold anything between 1 and 254. That's fairly important because basically what this is saying, if we go down a little bit more, is 48 for that. That's a network number. And then we got a broadcast number. It's 63. And how do I know this? Is basically I use a technique called a magic number. Basically what I do is I take a look at the last number in the sequence, in the last octet that will be in place. And basically what we take a look at is, so 1, 2, 4, 8, 16. So this last one, 16, as we can see from up here. And basically you need to always have a net and a broadcast. So those are automatically taken. So subtract 2 from whatever it is. So for example, in this case, it's 16. So you just subtract 2 from that, and that gets you 14. Simple as that. Well, what you need to do is add 14 to whatever this net is. In this case, it's being 48. and that is 62. This is your usable host. And you just add one more, and it just gives you the N number. So in this case, it's 63. But we can use anything from 49 through 62. Hopefully that makes sense. So in this case, let's just say I'm just gonna say 1 here. Just say that we're going for 1 at the end. It's still a 16, right? 0 will be the broadcast and act statements, and 0 would be the network, and the 15 would be broadcast. And because again, you take the last number. Again, this is called the magic number. You just basically look at the last true, and this being 16. What you need to do is subtract 2 from there, and add it to whatever the network is, and that gives you the host, the last host. So just add 1 and then add whatever that is. So in this case, being 14 into that, and that gets you 62 in this case. And then if you add 1 more, that gives you the broadcast range. So that's fairly simple in itself. It's fairly easy to do right there. It just takes a little bit of getting used to. But this is very much necessary for the CCNA. If you don't know this, I would not advise you to take the CCNA. You need to know this before you move into the tests of CCNA, CCNP. So as a example, I just did this off camera, so you won't have to sit through me doing this entire thing. I've been a little bit too big. So as far as this goes, I did a /9, and in binary, it's just 9 ones, and that is a 255.128.00. And doing this, basically what I found is the net is 192.128.00, and the broadcast is 192.255.255.255. This is fairly important to note, because what is the actual last one we took? And this is where the magic number comes in. So we got 255, and in this case, it's because it's all zeros. It's gonna be 255, and 128. Do what I told you before, and you'll get 255 for the broadcast. And what that will get you is, for the entire host range, it's 192.128.0.1 for the starter range. For the end of it, and this is usable host, 192.255.254, and that is a total of 8,388,606 usable hosts. So something like a metropolitan area like I don't know, New York or something like that. Well, I mean, that's even actually well beyond that, because I'm pretty sure they don't have 800 or 8 million houses and businesses it goes to. So I could be wrong about that. So I've never been in New York, so I don't really actually know how big it is. But something like this you'll see in ISPs. This is quite big for regular positions, network engineering positions, but internet service providers, that is something that you'll note. So with that being said, it is very important to note how to do these large numbers. I think it's more important, like if I was teaching this or whatever, I think it's more important to understand just the basics on how do you get it in the first place. But it's also important to note that, all right, so right here we're getting nothing. This is automatically a 255, and then we add that. So the 128 plus 128 equals 256. And is it 120? Yeah, 128. 28, 256, maxing goes 255. And what you need to do is that's your broadcast. Then you go into here, subtract 1, and that's your end of your host range, usable host range, plus 1 on here, and that's your start of your usable host range. And then just figure out what that is altogether, and that's what it comes out to be. So it's fairly important to note that. Like say for example, if you actually need this amount of devices, then there you go, and you have it. It's very important to note this with subnetting, because if you only need set amount of devices, like 50,000 devices, 100,000 devices, 1,000,000 devices, or 10 devices, having a subnet that is too big, having something that is too small is not good for anyone. But having a subnet that is too big is just a waste of resources, and that's just something that you really have to note, especially on the larger end scale. Also, with home use, you probably don't have to worry about that much, and it's whatever. But in office and whatever, it's fairly important with resources. So a question that will come up on the CCNA and maybe CCNP, but definitely CCNA, is something like you are needing so many hosts as far as so many users going to be using a system. Which one is right? So for example, with this is there is 123 hosts needed, and is /24 /25 /26 / whatever. Let's just do that. Which one of these are right? So /24, as shown above, it's 255 hosts. Keep in mind, you cannot use the broadcast nor the net. So for this one I just did above, the net I wouldn't be able to use, the broadcast I wouldn't be able to use, but so the real number for this is 8,388,608 hosts, but only have 606 usable hosts. So in this case, it's 255 hosts, but only. Oops, sorry about that. Wrong place. So for this, it's 255 hosts, but it's 254. Yes, I could use that, but it's too much. That's not what they're looking for. Like if you did it in my shop and you did 200 hosts and only needed 20 hosts or something like that, I ain't gonna have a fit. I mean, unless if it held me back in some other area, I ain't gonna have a fit. It doesn't matter much to me, but some bosses will, and this is a big thing. You need a answer for the test. They're obviously not asking for that. I mean, technically that's correct, but no. So in this case, what's /25? Well, basically it is 128. 128. And that means 126 usable hosts. We just need 123, and that's probably the closest you're going to get. So if 26 is 64 hosts, and that's obviously way too little. So basically your choice is going way too much and wasting a bunch of resources, way too little, and that's obviously going to be not true to start with, or just just slightly above, being close enough type of thing, and that's what you got. So the /25 would be the answer for that. So it's important to note that that to know this is basically what you can do is if you know how to make it into binary. So like in this case, /25, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that, and basically the based on this, it's 64. And I mean, we can go into it, but it's would be 128 usable host. Simple as that. What? I think I did wrong. Yeah, sorry about that. I actually added one more zero. But yeah, like I said, the last one is 128. And what that means is you have 128 hosts. One's going to be a net, one's going to be a broadcast. So that means you have 126 usable hosts, and there you go. Obviously, with this, with the 26, it's an extra one, and that would be 64, and that's where that 64 came in play. So, yeah, I mean, basically, you can get this in your head pretty quickly. Is 24 is it's a fairly very common subnet, especially for homes, and if you can get in your head that it's 255 0 for /24, well, add 1, and if you add 1, now we're at 128. Add 1 more, it's 64. Add 1 more, it's 32. So on and so on. So with that being said, that's just something that you got to keep in mind. You don't actually need to put it in binary if you keep that in mind. If you look at /24 and you see, that is 0 at the end, and then the next one's 25. Based on this, which you should have learned earlier, which was earlier in the video, you'll know that that extra 1 is 128, and you can do it right there. So with that being said, that's pretty much that. Oh, and something else that will be on the CCNA is something like this, and this is actually fairly common that you'll run across. This is you have several networks that you got to make they got to do it for. So we have 34 hosts, 32 hosts, 64 hosts, blah blah blah, and this is something that's fairly important. They'll in a test, basically they will say which one of these subnetworks which you need to go with. And they'll give you like 255, 255, 255, whatever. So in this case, we got 128, 192, 224, 248. And putting in binary, this is why it's important. Putting in binary, 128, it's 1 blah blah blah, and the magic number for that is 128 for For this, it's 64, 32, 16. It's fairly important. Now, what you need to do is 64 goes in 192. But basically, what you need to do is find one that like say for example, 32, 32, 32, 32. So it's like too much right there. Just for example, it's not enough for it's not big enough for this. It's actually big enough for that. No, sorry about that. It's not big enough for that because of the 2 minus. It'll be 30. Broadcast network will take 2 of them, so it'll be only 30 of them. In this case, it'll be 64. It'll be this one because the broadcast in the network takes 2, so it'll be 62. Right, and the magic number says it's 64. Right, so we need only 4 networks. So what we have is that's the 64. So what we have is 64 plus 64 plus, sorry about that, 64 plus 64 equals 128 plus 64, which equals 192. And there you go. It's fairly important to note that. I mean, obviously, if this was like 120 or something like that, then you kind of would have been stuck with something of this nature. But it's just important to note that in order to get the 4 host four things, you would need to be able to put it in binary, find a magic number, and go through that route. Oh, and one last thing, I'm sorry, is know the magic number. So I'm just use this as an example, 16, right? So basically, whenever you're doing something like this, and the reason why we're starting at 0, what you need to do is start with 0. So 0, and since the magic number is 16 in this case, we go by a 16, and then go up 1, 32, 48, 64, blah, blah, blah. And basically this, these are not usable. These basically are not usable hosts. These are network numbers. So just note that. It's fairly important to note this because, say for something like here is, if you had a test question to say, is 192.168 whatever 1033/28 is a usable host number. Basically what we can do is go, we know 28 is the magic number for that is 16, since we took in binary or whatever, and from there it's 0, 16, 32, and we can do the math. Obviously we can see from here and say, yeah, it is, but just doing the math, it's 32 and 47. So as far as that goes, that's just something that you might run into. So just note that, because the thing is there's a lot of trick questions like that. There's a lot of trick questions on CCNA. It's been a little while since I talked to the people who makes the CCNA, but they're telling me that they just put more trick questions on there to keep it hard, because too many people are getting CCNA, CCNPs, and it weeds people out. Unfortunately, it's what you gotta do when you get too many people getting a certification. But anyways, as far as that goes, hopefully this helped you out. If it has, then leave a like, subscribe, share, whatever. But if it hasn't, more importantly, feel free to let me know down below, and I'll try and answer as quickly as possible. And feel free to check out my other videos. I got plenty of videos in CCNA material, network engineering material, coding, and hacking, and whatever. But anyways, I'll see you next video.